Series circuits. I think we're running out a little bit of time, so I won't review too much, but I'd come over here to the battery and say, what's your job?
To provide energy for Coulomb.
Very good. X. Where's your Coulomb? Up here. Where's your Coulomb? Your Coulomb's high, right? Your Coulomb's up. Your Coulomb's up. You guys have to go behind the camera. Up. Here. And your job, light bulb, is to?
Use that energy up. Use Coulomb's up.
Use Coulomb's up?
Well, I will use energy.
You're going to use the energy to do something. I'm being a little nitpicky here. Okay. The nitpickiness is that energy isn't really used, right? It's just converted, and for sure the Coulombs aren't used. So then your energy is down low, right? Down low, down low, down low. Where's our? This is the other light bulbs. Yeah, with a she smiled too. Okay.
That's true.
Okay, so your light bulb. Now, what's your light bulb? What's your job?
Transfer the energy?
Oh.
Or use it up? No.
You don't use the energy. Well, you convert the energy into a different form, right? So you get the energy here, and then where'd you pass it off?
Me here?
You're going to lift it up? Do you have any energy to? Something's wrong with our model here, isn't there? You see what I'm saying? Like the energy's down low here, and energy's down low there, and you need some energy to work. And if I had a light bulb at the beginning of the class, I'd say, when we had two light bulbs in series, one after another like this, it did work. What's wrong with our model? Like, it worked. What's that?
You use up less energy.
You use less energy? You'd convert less energy. About how much? About how much would you think would be fair? About half? If you were exactly the same type of light bulb as she was, about half would make sense, eh? So what you're saying is then, if you had half the energy, right, to spin around, you wouldn't be able to spin around as far, would you? Right? Right, so maybe you'd only get halfway around? So does that make sense? Okay. So you get the energy at shoulder length, and you have to pass it off about halfway down, about chest length, right? And you're only going to get halfway around, aren't you? Right?
Yeah.
And then where's your energy? About chest level, about halfway? Halfway. Now, do you have energy to spin around?
A little bit.
A little bit, about the same amount as that, only it's the other half.
Okay.
And you're going to give your energy off down. And since you only have, excuse me, I'm starting to lose my voice. Since you only have half the energy, you can't spin as fast. You're only going to get halfway around, aren't you?
Right.
Okay? And then the energy is going to be low here, right? And low there, and low there, and low there. So you have half the energy, and you have half the energy. You're spinning a little slower, aren't you? So you're going to be a little less bright. And you can use that. Got it? And isn't that what we just saw at the beginning of class? And aren't we starting to model that? And it kind of makes sense a little bit? Okay? So why not we start passing a little bit? See if it works. Okay? You ready? Pass. Remember, it's got to go down chest height. Pass. Got to go down. Now, gee, this is really slow, isn't it? It's kind of confusing for these light bulbs. The current has really slowed down, but isn't that what we saw, like supposedly at the beginning? Okay, pass. 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 Okay, now with students, you can start emphasizing the fact that it's kind of tricky for these guys, so the current's slowing down. Now, of course, light bulbs don't have trouble using half the energy, and they do burn less bright. But that's not the reason why real circuits slow down. But it kind of reinforces the idea that when you put two light bulbs in series, the current slows, and the bulbs aren't as bright. And we could also, if you need to review the voltmeter would come out of the circuit, measure the energy gain at the battery, and then, and look what's happening as I'm doing this. What have I got in my hand here? That's not there. A meter stick. I've got a meter stick in my hand that's not there. You didn't see it, you should see it. And then I come over to the battery with my meter stick that's not there, and I say, and the battery gives 1 volt of energy to or 1 joule of energy to every Coulomb, or 1 volt. And then I take my voltmeter and I come over to this light bulb, and what do I measure here in voltage? Half a volt, right? And then I come over here and I measure, and I'll bend down because of course it's lower down, another half volt, right? So we can say, the energy that the battery gave the circuit is equal to the energy loss here, the voltage loss, plus that voltage loss. And we're just reviewing and getting them to predict what's going to happen when we start wiring real circuits. That's the point of it. so that they're not just looking at numbers that have no meaning.